no one can tell you that you're wrong. If someone tells you that they're wrong, they are trouble. They are not mathing properly. Okay. So, the next question that we got today is, what is the antiderivative of 1 over 2x? Antiderivative is a nice fancy way of saying integral. Equals integral. Okay, so essentially it's asking us to find the integral of 1 over 2x with respect to dx, or with respect to x. Because when you take an integration or an antiderivative, you have to say with respect to which variable are you doing it with. Okay, now the first thing that I think would be a nice thing to do is factor out all the constants of this equation. Do we see any constants? Hey, the 2 on the downstairs. Hey, maybe we could factor out that 1 over 2 to make it look like this. 1 over 2, 1 over x dx. Okay, now this is a little bit easier to deal with. What this essentially is asking is something, or yeah, it is something where the derivative is 1 over x. Now, do we know anything that has a derivative that is 1 over x? Let's think about it. Let's think about it. What's the derivative of natural logarithm of x? D over dx. What's that derivative? It's 1 over x. Hey, so it must be a natural logarithm. Now, a thing I want to mention is that it doesn't specify that x has to be smaller than something, because, you know, if you put a negative number in here, you're in trouble, because natural logarithms, all logarithms for that matter, they don't play around with negative numbers. They don't exist. They don't have answers when their input is negative. So because of that, we don't know that x is going to be always positive. So we have to accommodate it possibly being negative with an absolute value. And you'll see what I mean. So this goes down to here. And the result of that is 1/2 times natural logarithm of x. Notice how I'm putting these vertical bars. That's just to specify that it's absolute value, because we don't know what about x. X could be negative, and natural logarithms, they don't play around with negatives. And something you can never forget, plus c. If you forget the plus c, you will see C's and D's and F's. If you forget the plus c, it's super important, so don't forget it. Now we can expand this out, and this is equal to ln of x over 2. Now it might be tempting to say like, oh, c divided by 2. Well, I guess that is right, but that's just a different constant. So anything that you do to a constant, you can pretty much just leave it as a constant. If you're just like multiplying stuff to a constant, you can just leave it as plus c. So let's just leave it as that, plus c. And that will be the answer. The reason why plus c is important is that the derivative of this, if c is a number, it's always going to be like 0. If we took the derivative of this, and we would see that we get the same as the original. It's just like if you do multiple integrations, forgetting a c will be certainly problematic. You're going to forget some terms, and it's not going to be a fun time if you forget the c. So you got to see the c. Okay, so they came to the same conclusion. Half natural logarithm, I just wrote it a different way, plus c. That's the key. C is the key. So the above solution is good.